Hey everybody, this is Mr. S, and we're going over lesson 7 with the Addie unit on bacterial resistance. And in this lesson, we're going to talk about how do bacteria get killed, and we're thinking about how many doses of an antibiotic would take to eliminate 1,000,000 bacteria if it was 90% effective. So I think we should create a mathematical model to help make sense of why we might need multiple applications of a product like hand sanitizer or multiple doses of an antibiotic for them to be completely effective. So we are going to look at what if we had 1,000,000 bacteria and we're using an antibiotic that's 90% effective, how much bacteria will it kill? So here's our handy dandy calculator. And let's say we are doing 1 dose. We would have 1,000,000 bacteria to start off with. Okay. And if we took 1,000,000 and 90% of the bacteria were killed, or 90% is effective, it would look something like this. 1,000,000 times 0.9, or 90%. And that will give us 900,000. So that's how many were killed. And then the amount that are left are 100,000. So I'll have to rewrite it because of how this works. So we have 1,000,000 here again. Okay, so we know that 900,000 get killed. And that leaves us with the difference of these two. So that would leave us with 100,000 left. Okay, so that's how many we have here, right, before the dose, because we have 100,000 left. Okay, so 100,000, dose 2. If we took 100,000 and we multiply it by 0.9 again, we would see that 90,000 were killed. Okay. And that leaves us with 10,000. Okay, so this should be really quick and snappy for you. You just take this number, multiply it by 0.9 for 90% effectiveness, and then however many are left, go here, and also that's how many we start with. So for round 3, we're starting with 10,000. Okay, so you can fill those in and then try to fill in the rest of the table and show me, come check with me when you're done with that. Okay, so when you're done with that table, you're going to make it into a line graph. Okay, so here you have the number of antibiotic doses, and here on the y-axis, the number of bacteria left over. Okay, and I kind of abbreviated it. You can write the full numbers, but we started off with 1,000,000, and we want make sure that these are evenly spaced out. But we know we're going from 1,000,000 to 0, and there's 10 intervals, right? So we would spread it by 100, 200, 300,000, 400,000, 500,000, 600,000, 7, 8, 9, all the way to 1,000,000. And then we just look at the table and see, all right, how many bacteria were left after 1 dose? And I can tell you that we had 900,000 left. Okay, and then you'll make the rest of the points, wherever they may be, and then you'll make the line. I just randomly put those, but you're going to make your own line and then start interpreting that. All right, so now we're going to calculate it a little more in depth, okay? So there's a little more information here, right? So we have initially 1,000,000 bacteria. So that's what we're going to start with here. Go ahead and fill this out with me. Okay, And then we took our first dose of antibiotics immediately, right here. And it was 99.99% effective. Remember, that would equal 0.9999. Remember, this is important. If you ever want to go from a percent to a decimal, you just move the decimal over 2 times, and that will give you what the decimal is, okay? So any surviving bacteria continue to double every 20 minutes, and then we took another antibiotic dose every 4 hours for 24 hours. So this is the number of hours, and every 4 hours we take another antibiotic. Okay, so how do we do this? To find the number of bacteria after a dose, okay, so you take the number of bacteria before and you subtract it by the number of bacteria before times 0.9999. That's the 99.99% effective part. So take out your calculator, and in this case, we multiply 1 million times 0.9999. You'll see that that will give us 100, or yes, that will give us 900,900 bacteria alive or killed. And then we subtract that from this and we get 100. Okay, because 1 million times 0.9999 equals... All right, so the antibiotic would kill 99.99% of the 1 million, which is 999,900 are killed, and it leaves us with 100 alive. Okay, and then that will again take us to 100 alive here. Okay, now pay close attention here. So now we have the bacteria double every 20 minutes, and then we wait 4 hours to take the antibiotics. So if they double every 20 minutes and these are hours, it means it doubles 3 times per hour. And that's the same as multiplying by 8. So for the second hour, we would get 800. 800 times 8. Get 6,400 because they're doubling 3 times every hour. Okay. $51,200. Okay, but now we reached hour 4, so we get an antibiotics. So now we're going to take 51,200, multiply it by 0.9999, and then take that number and subtract it from this bacteria before, and you'll have however many survived. All right, I'm here to help you. I want you to fill the first 12 of this. You can write this down on your student activity sheets, and then we will work together to answer the fill in the graph. So you'll graph this on the graph sheet that comes next, and then you'll work on questions 6 and 7 in the student activity sheet. Okay. And we will go from there. Okay, good luck. Let me know if you need help, and we'll see you soon.